Okay. All right. I'm going to start. So welcome, everyone, and thanks so much for joining the session. My name is Bryce Bartmann. I'm the Chief Digital Technology Advisor at Shell. I'm also part of LF Energy, so I sit on the governing body. I'm also on the Technical Advisory Committee, and I chair the TSC for the project I'm going to talk about today, which is RTDIP. Just a quick note, there are some forward-looking statements in here. Do with them as you will, but please don't trade or do anything silly about the information I'm about to share with you. So the agenda, I wanted to focus on a few things in this session. Shell joined LF Energy in November last year. I wanted to spend a little bit of time focusing on why we did that and try and give some context as to where we want to go with our investment into LF Energy and also what we want to build with them and where we think that this is applicable in the energy system. I also want to talk about our just general strategic and tangible values that we hold around open source and what we want to do as a company with that. I'm then going to go into a bit of a technical conversation around what RTDIP is and what all the components are that go into it and how it's applicable to different solutions in the energy sector. And then if we have some time at the end, also just talk a little bit more about what we are doing with this product already in Shell and also its application for the energy transition. So let's get into the why. We are seeing a major shift in two areas that we are identifying. The one is the energy system is transitioning. There is no doubt about that. That is well underway. The oil and gas sector also needs to respond to that, and you probably can see from what Shell is doing, we're working really hard on the energy transition because the energy mix is changing. We're also seeing massive efforts going into decarbonization. There's decentralization of the energy system. And we're also seeing a difference in the market. So there's non-traditional competitors that we're also having to work with. And there's also new business models coming out that we know we need to address. The other that is happening at the same time is that digitalization is happening at a rapid speed right now. So we are seeing a change from a very IT-focused world into how do we digitalize and turn everything into something that we can use and interact with in a digital way. And there's a lot of opportunities in that space. There's a lot of business models we can explore. And we need to see what we can do about that in the energy sector. And the other is that we're also, and I don't think we would have said this maybe 5 years ago, but we're also seeing customer engagement increasing in how their energy is being generated and consumed. And so we need to just make sure that we address that. And digitalization, we believe, is one of the key factors to making that happen. So we have where we are today in terms of an energy system. This is a slide that covers what we think an integrated clean energy system looks like. There are a lot more components to it than something we would have seen a few years ago, and it's a highly integrated system. So we're talking about CCS and electrolyzers, blue hydrogen, gray hydrogen. How do we deal with all of that? We've got EV charging, solar farms, and an integrated energy system is becoming something more complex to manage. But it's also something that we need to digitalize so that we can optimize it on a continuous basis. We've got obviously a long way to go, but this is where Shell is focusing its attention in terms of how it's going to build the next integrated clean energy system. So with all of that in mind, we do have to transform the energy sector. Shell is obviously a big part of that, and we want to make sure that we can do what we need to from our side to transform the energy system. Where I come from in the business, digitalization is a key part of our responsibilities, and we're working really hard to make sure that we can transform the energy sector as we want to and need to do it. And there are a few key enablers for that. And one of them is open source, and this is fundamental for us. We are seeing at this time, digitalization solutions are very much built on open source solutions. So everything that I think we interact with, probably even the way I'm displaying the screen, is built on open source technologies. So we need to make sure that open source is front and center to how we build that next energy system. We are working really hard to try and change that culture within Shell from thinking about proprietary software only to start working in an open source way. And we know that that's going to help us to get to where we need to. And it's through a couple of, we've identified a few key areas where we are focusing a lot of our attention. So data has been fundamental to digitalization. Probably most of you who work in the energy sector know a lot of our assets are not digitalized. So we don't have electronic versions of even the drawings that some of them are based on. But when we do, and we are able to provide that and make it easily accessible and for people to query and find value, it drives innovation. And we have seen an explosion of innovation in our part of the business by just making real-time data available. And I'll talk about that a little bit later. The culture is also needing to change. So we're seeing, not only from inside, but also from people wanting to work for Shell, that they want to work in an open source way. They want to interact with tools like that. They want to be a part of communities like LF Energy. And we're trying our hardest to make sure that we are a part of that journey as well. We have something within Shell called Shell.ai, where we have over 10,000 people who have joined that community. And they talk about topics like we're talking about today on a regular basis. We engage with them all the time. And we try and bring them along on this journey that we're going on in terms of making open source a part of how they think and how they work. But they're also asking us to make sure that we're doing that as well. And that also leads to access to talent. So we also know that we're going to need smart people. This is a highly competitive environment. And they want to work in these environments. So we want to make sure that we can access the people we need to help us go through the energy transition as we plan to. So open source is a key enabler for us. So let's just talk a little bit about our strategic values. And this is what we're seeing on a daily basis, and I think most of you will probably agree with this as well. We've been working on open source. I guess most people join it because they want to define standards and they want to be able to support interoperability. And that is obvious in some of the reasons why we want to do open source. So collaboration and support of integration is important. Increased interoperability is making it easier for us to find solutions with each other. So one of the common problems that we have at Shell is that we buy software or hardware, I should say, and the supplier of that hardware will say, you need to use our cloud, our hardware, our applications, our intelligence in order to leverage it. And for us, that's not great because we want to be able to store that data in a common model that they can build that intelligence on. We can't build all of that intelligence, but we want to be able to use that data for much more than just that single use case that they come up with. So we've been trying to work as hard as we can, even before we joined LF Energy, on can we define standards where the data that your equipment generates is all in a format that we can all agree to use so that we get what we need for our use cases, and so do you. And so RTDIP is very much ingrained in that kind of thought. So it's come out of a lot of work that we've done with our suppliers of equipment on that. We also think that it's important to create a level playing field. If we only allow people with extensive amounts of money to be able to build and sell us solutions, it doesn't encourage competitiveness or innovation from some of the startups that maybe don't have access to all of that financial support that they need. We also think that, and this is probably the message from this morning, that by collaborating, we'll be able to go through this energy transition quicker. And that's becoming more and more critical. We see that every day now, that we need to move faster in the energy transition. And it's no longer about how we're going to fix the energy system. It's we are now fixing the energy system. That message is changing. And then we're also doing a lot of work on focusing on electrification of systems. So you'll see us talk a lot about the work that we're doing to change industries that aren't using electricity to now think about ways that they can. So in November last year, we joined LF Energy. It took us quite a while to get to the point where we could join up. It takes a lot of internal debate to get to that point. We're really proud to be a part of it. The first contribution that we made is called RTDIP, and its primary purpose is to make access to process data or real-time data much easier. We built it out of a necessity for our data scientists to explore value in data, mostly around predictive maintenance. But we've seen an explosion of use cases for it all over the business. So today, the real-time data ingestion platform at Shell is deployed across the globe. It runs from Canada to Australia and every asset in between. It currently ingests in real time over 3 million sensors on a 24/7 basis. We've collected about 4 trillion rows of data since we've deployed it a couple of years ago. And it's supporting all sorts of use cases. Like I said a little bit earlier, it was supporting predictive maintenance, which is a big program that we've deployed, which is monitoring 17,000 pieces of equipment in real time. But what it's also been doing is, when we did that, we decided to build a data lake that we could store all of the data in and see if others wanted to use it. And that was one of the best decisions that we made. We organized in a way it was easy for people to find, and then the use cases started to come. Right now, we've got about over 50 applications that are running on top of this data that are doing things like data science, AI, analytics, or even basic Python functions. And it's getting deployed in lots of different places. It works, and we run it in our LNG business, in our upstream business, in our manufacturing sites, retail sites. We even use it in smart buildings. And all it's doing to try and demystify what it is collecting the data coming from sensors and storing it for archival purposes so that we can query it later. But we always designed it with data science in mind. That was always the fundamental goal. And that has also worked nicely with how digitalization has matured, where we've gone from data science was some algorithms to now where we are today with generative AI being so front and center of everything we talk about. And we've been able to be part of that journey. We also spend a lot of time kind of innovating on this concept as well. We work with these communities that we're going to talk about in a little bit, or show you in a little bit, which is highlighting how can we take data where it is today and modernize it and keep it modern, and keep up with all of the demands that come along with managing data. So the core capability of RTDIP. RTDIP is, I guess the best way to say it is a data engineering platform that allows people to query time series data. Sources, if you're in the energy sector, you'll know that we have data coming from all sorts of places: substations, solar parks, wind farms, could be oil rigs, smart meters, weather, all of that we define as time series data. We then will see in the implementation or deployment of an asset connectors that then connect to those data sources and push them somewhere. So if we're going to talk a little bit later with a team called Fledge Power about what they're doing with protocols like IEC 104, DNP3, and 61850, very common protocols that are in the energy sector. There's also another LF Energy project called Fledge that provides an OPC UA connector. There's another one called Edge Foundry that provides OPC UA. We also work with an open source connector from Azure called OPC Publisher. And what their job is just to connect to the machines and push the data to a message broker. So that's typically something like a Kafka server or an MQTT endpoint. And that is just basically creating a way to shift a message or real-time message from those connectors for something to consume. And that's where we come in. So once the messages are on those brokers, RTDIP has a pipelining engine that is built on Apache Spark, which is an open source technology. And it's all written in Python. And it can consume that data and push it into another open source technology called Delta Lake, which is a lakehouse concept stored in data lakes. So in the cloud kind of description, that will be S3 buckets or ADLS Gen 2 accounts. It can be on-premise as well. Delta Lake is not just cloud only, neither is Spark. And so you can build pipelines that can consume messages from those endpoints, coming in a data model from one of these types of connectors, storing it in a data lake, and making it easier for developers, like this person up here, to connect to that data, build pipelines, as well as query it. We've spent a lot of time making sure that the entire design of this is open source. You can run this in any environment you like to. We have over 300 unit tests that are behind our entire product. Those unit tests do not mock Spark or any of our engine. Those run in real time on all of our unit tests that we run. And it's running on a local machine. It can run on GitHub Actions runner. It can be anywhere. But the best place where we see it and how we use it at Shell is in the cloud. And so that is what we're doing to build a way to ingest data from sources like this. So the full set of components that are available right now, and we also have a roadmap available online if you go to our website, rtdip.io, that describes all the different sources, destinations, transformers that we are working on or we intend to work on. And some of them that are available here, so you can ingest from a Delta Lake in real time. There's also an open source protocol for data sharing that we use a lot called Delta Sharing. That's been a key component for us to be able to share data with third parties that need access to our data. And that was what I was talking a little bit earlier about, is how do we make it easier for Shell to share its data with its vendors who can provide us with particular intelligence that we need. There's also, we see event hubs used a lot, which are in Azure products or IoT hubs. If you're in AWS, Kinesis is another one that we can consume data from, Kafka, and then we also have REST APIs. For transformers, we are working as closely as we can right now with Fledge and EdgeX Foundry to make sure that we can consume data from connectors that come from them. We are going to be working with Fledge Power because that's obviously very key for us to make sure that RTDIP is relevant in the LF energy domain. And I mentioned those protocols that we're working on, that we will be working on. There's a bit that we have to do, and so does Fledge Power to be able to get that to a point where we can advertise that it's ready. The destinations. So at the moment, we consider Delta Lake the best solution for storing large amounts of time series data. Like I said a little bit earlier, we're running this at scale across the planet. Scale is not one of our major challenges, and Delta Lake is really key to that. But you can also use our pipelines to forward messages on to other Kafka endpoints or event hubs or Kinesis, or you can even send it to REST APIs. That is often something that people want to use it for. If you want to build pipelines and you need to access sensitive information, we've also got components that can connect to Databricks secrets, HashiCorp vaults, Azure Key vaults, and we will be building one for AWS Secret Manager in the coming quarter. We also have made it simpler for you to organize your data lakes. So we have components that can create ACLs, so access control lists, so that when you create your folders, you apply security to it. We've done the same thing for S3 buckets. For deployment and orchestration, this is a key one. So building a pipeline is great, but if you can't orchestrate it to run how you need to and when you need to, you're going to be missing a trick. So we have built integration to Databricks workflows. We've also got something that can run our pipelines on Airflow. And we've started working on Dagster, which is a popular open source orchestration engine that will help us schedule and run our pipelines for us. We're currently run on Azure and AWS. I'd say our most mature target is Azure. That is something that we've built the entire solution on. But because we've made open source decisions around how these components work, it was easy for us to move to AWS. And it will also be easy for us to move to GCP. We're meeting with Google shortly to work out how we can get the platform running on there as well. Getting the data into the data lake is one thing. Consuming it is probably the most important part. So when we started this journey at Shell, we didn't make it that easy for people to get access to the data. Reading a data lake is a foreign concept. People weren't familiar with the tool sets and how to use it. And we wanted to make sure that we could make the access to the data as easy as possible. So we have built, and this is where it started with us actually, we built an SDK that a Python developer could install, and it gave them access to queries that they just had to fill in what asset they wanted to query, what type of time series query they wanted to make, and then it would turn up in a pandas data frame on their machines that they could consume. And that made the data scientists really happy. But we've also got applications that are running on top of our data sets as well that either use the SDK or our APIs to query it. We basically, some of our biggest consumers at Shell of the data that we use in this is digital twins. When they come to us and ask for data from an asset, it's basically every piece of real-time data that you can get, because the digital twin, if it's missing some data, it's missing some context, and so it's not as useful. And so digital twins talk to our platform and use our data through that. And then what has really liberated the business is just supporting BI tools and analytics. So if you're using this particular solution in Databricks, they have a solution called Databricks SQL that allows people to log in with their Shell identities and single sign-on to our data and query it, so they can use Power BI to build their own dashboards. And that's been quite important to helping people adopt the tool in their daily processes. So the application for the energy transition. We are seeing this, as I've been explaining, coming up all over the place in Shell. It's quite liberating. I was at an asset last week where you go into different meetings and people are talking about this product from all different perspectives that they need to use it within Shell. So just some thought-provoking ideas is where else can we use this? And so we've been working on expanding this to lots of different use cases. If we go into some of them, we're also seeing the adoption of SSIP, or RTDIP as we call it, in our renewables and energy solutions. So our renewable assets are mostly connected to RTDIP. We consume their data in real time, and we're seeing data scientists starting to come up with really innovative solutions to running those renewable assets in the best way and the most efficient way that they can. We are also going to be seeing it being adopted in other sectors such as hydrogen, and we've been working really hard within our business for them to see the value in digitalizing their assets, but then also being able to consume all of the data that those assets produce. As I mentioned earlier, we are also investing in decarbonizing hard-to-abate sectors. So these are things like cement and steel. And we're working with some industries in India where they make their real-time data available. And so then that allows data scientists to come up with innovative ways to decarbonize those sectors. Down the bottom there, we're actually showing hydrogen electrolyzer, where we're working on a project right now that power is coming from solar panels. And then we're making that data available for people to think of clever ways to use that hydrogen for energy traceability. We're also seeing a lot of use cases for it in electrified chemical reactors. So producing hydrogen, the most important part is the energy that comes from splitting hydrogen is from renewable sources. We're connecting a lot of the solar parks that we have to the real-time data ingestion platform. We're also starting to see smart ways of modeling our systems. So it's been liberating for data scientists to have access to the data to do system-level modeling instead of having to build the real thing, and coming up with innovative ways to solve it. And then the other thing that we're also been doing a lot of work on is better cooling of EV batteries. So there's a lot of work that's going into our fluids business to try and come up with cooling systems that can help batteries. And then lastly, we're also doing a lot of work around sustainable aviation fuel. So you would have heard about a project, hopefully, called Evelia, which is all about tracing sustainable aviation fuel. Obviously, there's real-time aspects to that, and we're working with that team. And then there's safe storage and transport of hydrogen. So, as I was mentioning earlier, the hydrogen business is talking to us a lot, and we're looking at how we can move hydrogen around safely and transport it in a way that doesn't create risks for everyone. So a lot of those use cases are based behind Shell's Powering Progress strategy. We are working to improve all sorts of parts of the business from a digitalization perspective. The real-time data ingestion platform has been key to what we've been doing in this space, and especially in the digitalization space. And that's why we thought it was important to contribute the RTDIP solution to LF Energy. We're really looking forward actually to working with some of the other partners in this area. We've had a lot of conversations today just about how we can integrate, and we can see a lot of opportunities for that. We've also got some amazing contributors who we've been working with. So InnoWatts is a company that has been helping us build some of our weather and smart meter ingestion capabilities that are coming to the platform. We'll continue to do that this year. And then we're looking at anyone who's happy to come and help and contribute with us. I know there's some people in the room that we've been talking to. Would love you to be a part of that story. So that's a little bit about the RTDIP product. If there's any questions, I'd love to table them. I know it is hot in here. I know it's late in the day. So let's see if anyone's got any thoughts or any questions on anything I've presented so far. Yes?
I've followed Shell for a few years, and have even got the proof of OZSoft's and I mean, this sounds like it's going to replace the whole of massive OZSoft infrastructure.
It's quite wise that you know all of that. Okay, so yes, where the product came from was RCSoft Pi. For those of you who don't know, it's a historian that is installed I think it runs in 80% of oil and gas assets around the world. Its primary function is to capture time series data. The architecture is designed for more on-premise types of capabilities, and it's got a rich ecosystem around it. The challenge that we have with that design is that we aren't able to build data science and AI at the scale that we need to. So when we started this project, we actually built a connector from Pi to push it to the cloud so that we could then build AI on top of it. And that has been the success story for us that opened up a lot of opportunities. So once we could prove we could consume data from a system like that and store it in the cloud in a way that it was easily accessible, we then saw lots of other things. So now the conversation has changed from pull it from our RCSoft Pi systems to go straight to the source. So that's why you see us working on things like OPC UA, OPC AE. That's why we're looking at DNP3, 104, 61850 is because people believe in the system now that it is suitable for the same kind of functions that RCSoft Pi would do, but in the cloud. And so that's where we're going with it. Now, I'm not saying that we're trying to replace RCSoft Pi. I think RCSoft Pi has a very rich ecosystem that still serves amazing purposes today. It's just that I think in terms of making something more applicable to where we're going with a modern tech stack, that's where SSIP or RTDIP can really play a part in that story. Any other questions? No? Okay.
One question. So you showed the orchestrators with Dagster and with Airflow and so on. What's the value of having multiple different orchestrators?
So it really depends on how you want to deploy the solution. So if you are a Databricks customer who run Apache Spark in the cloud, you're likely to be using something like Airflow or Databricks workflows. That seems to be a common architecture that we see. Dagster, however, is a little bit of a mix between it can still help you run stuff in the cloud, but it can also help you run it anywhere else. Airflow can as well, but we're just seeing that it's much simpler to test with a product like Dagster if you want to test pipeline development. And it just has, I think, a few more like open source traits that make it really appealing. So one of the other projects we were talking to today, we're also really interested to see that we were talking about Dagster and that we're building it in. And we just want to appeal to different parts of the sector. Even within Shell, you'll see a split between different types of orchestration engines and who's using what. And just to even satisfy the demand there, we just want to make sure that we can cater for all of that. There are actually a few others that we might look at as well if we get the time to build all of that. But we think by satisfying those orchestration engines first, we probably got most of our audience captured.
Thanks.
All right. Okay. Any last questions? Late in the day, hot in the room. Yeah, I can feel it too. All right, well, thank you so much for attending the session. Really appreciate it and hope to chat with you soon. If you have any questions you want to follow up with, please chat to me now. Thanks.